Hi dear students, let's go to the second chapter, Polynomials. Let me give a small introduction about this chapter, Polynomial. Already you are familiar with the term polynomial because in your 8th class and in your 9th class, we have studied about monomials, binomials, trinomials and polynomials, right? So this is a term which is derived from the algebra. We can say it's a branch of algebra. Actually, we are going to deal with some variables and some numbers together. That's what the study of polynomial means. So exactly as you have studied in your 9th class, every polynomial in x will be denoted by p of x. P, then after that within brackets we will write x. P of x, we will read it as p of x, p of x, right? That's what we call polynomial in x. If it is p of y, that means the variables will be y. If it is p of t, the variables will be t. Okay, hope you understood that much. Now let me give an introduction to this chapter. See, in this chapter we are going to study about different types of polynomials, especially quadratic polynomial and cubic polynomial. That's the main topic of this chapter actually. See, this chapter is so important because the upcoming two chapters, linear equations in two variables, chapter number 3, and quadratic equations, chapter number 4. These three chapters are interlinked together. It's very important because from here we are going to get the base, and from this base only we are going to build the total of the other two chapters. That's why I tell you this is so important. This chapter is so important. So here I'm going to tell you the basic things which we have to know about any polynomial. First of all, let us discuss about degree of a polynomial. What is called by degree of a polynomial? If a polynomial in x is given, if you are seeing the highest power of the variables, here anyhow if it is p of x, the all variables will be in x itself. So what is the highest power of x in the given polynomial? You have to check it first. When you are checking that one, if you found it as 4, then we will say it is a 4th degree polynomial. If you found it as 3, if you are understanding that the highest power is of 3, then we will say it is a 3rd degree polynomial, means the degree of the polynomial is 3. If it is 2, means something, just imagine that x square plus 2x plus 1. It's a 2nd degree polynomial. Why? Because here you can see x square is there, x is there, and third one finally it's a constant term. So here the two variables are x square and x. Which one will be the biggest one? X square obviously, right? So the biggest degree or the biggest power is what 2 is. 2 is the biggest power. So we can say that the degree of this polynomial is 2. Last year in 9th class we have studied about linear equations. That means a linear polynomial. A polynomial of degree 1 is what we call linear polynomial. How can you understand the degree is 1? Just by checking the power of the variable. Means in general we will say like that, a general form of a linear polynomial is ax plus b. Px is equal to p of x is equal to ax plus b. It's a general form. Ax plus b means something in x. A and b are constant. It can be any integers. Okay. So ax plus b means 7x plus 3. 7x minus 4, 8x minus 3, like that, something x, then a constant number. That's the general form of a linear equation. Now, if after finding the degree of an equation, if the degree of an equation is 2, that means the highest power of the given equation, if it is 2, then that polynomial is what we called a quadratic polynomial. Clear? So quadratic polynomial is a polynomial having its degree 2. And if the degree of the polynomial is 3, if you found that the degree of the polynomial or the highest power of the given polynomial is 3, then that typical polynomial is what we call cubic polynomial. Further, if the degree is 4, that is what we call biquadratic polynomial. So in this chapter we are going to discuss about quadratic polynomials and cubic polynomials, because about linear polynomials we already has completed the topic in our previous year in 9th class. We have completed that one. Okay, so in this class we are going to discuss about basically about quadratic polynomial and a cubic polynomial. Now, let me introduce the next term. Now you understood what is the degree of a polynomial, right? And just by seeing the degree of the polynomial, how will you name it? That's the two things which I have mentioned right now. Now the next one which you have to understand is zero of a polynomial. What does it mean by the term zero of a polynomial? Because in plenty of questions we are going to find like this, find out the zero of the polynomial. Check whether it is the zero of a polynomial. These are the things which we are going to study in the further exercises. So you must know about the term zero of a polynomial. So what is zero of a polynomial? That means if a polynomial in x is given, so as just imagine p of x is equal to ax plus b, it's a polynomial in x. Inside this polynomial, for what value of x, because x is a variable, what does it mean by variable? A thing which is varying means a thing which is having which can be received numerous values is what we call variable. In the term variable lies the meaning of the sentence, right? Variable, varying. So we can say x is the variable here. So instead of x you can give any values. Ax plus b. Inside ax plus b, if you are giving the value of 2, what it will become? 2a plus b. If you are giving 3, 3a plus b. If you are giving 4, 4a plus b. Means whatever value you are giving for x, p of x will be that one. So here zero of a polynomial means for what value of a polynomial, for what value of a variable will it become 0? Means if the total value of the polynomial became 0 for a particular value which you gave for the x. That means instead of x, substituting a particular value for x, if you got the whole value as 0, then that particular value which you have given for x, that means the value which you have substituted for x is what we call the zero of a polynomial. That means, see, 3x plus 2 is equal to 0. Okay, it's a linear polynomial, right? 3x plus 2 is equal to 0. So here 3x plus 2 is equal to 0. That means the value should be 0. For what value of x will this become 0? Now 3x plus 2 is equal to 0. That means 3x is equal to minus 2. Taking this 2 to that side, 3x is equal to minus 2. Now x is equal to minus 2 by 3. If you're taking 3 to the right hand side, you will get x is equal to minus 2 by 3. What does it mean by x is equal to minus 2 by 3? It means that if you're giving in the given polynomial 3x plus 2, instead of this x, if you're replacing the x, if you're substituting the value minus 2 by 3 for x, the total value of this polynomial will become 0. That means minus 2 by 3 is the 0 of this given polynomial. Hope you understood the meaning of 0 of an equation. Means if you are substituting a particular value for that one, if you are getting the total value, if becomes 0, then that particular value which you have substituted for x is what we call the 0 of a polynomial. Is that clear? Now see, we have today I told you about linear polynomial, quadratic polynomial, cubic polynomial, biquadratic polynomial. Linear polynomial means it is having 1 as its degree. Quadratic means 2 will be the degree. If 3 is the degree, we will name it as cubic. If 4, it's biquadratic. Now there is a relationship between the degree of a polynomial and the number of zeros. Means it can be, see, the zeros can be numbered. That means the zero, never think that there will be only one value. No, it differs. Sometimes there will be 3 values, sometimes there will be 2 values, sometimes there will be 1 value. How can you understand that whether the zeros are of, means it's having only 1 0, or it's having 2 zeros, or it's having 3 zeros, or it's having 4 zeros, or it's not at all having any zeros? How can you understand this one? Just by seeing the degree. If the degree of the polynomial is 1, I mean for a linear polynomial, it will be having only 1 0. For a quadratic polynomial, that means a polynomial with a degree 2. So for a quadratic polynomial, the total zeros will be 2. Now tell me, what about cubic? Right, 3 itself. For biquadratic, there will be 4 zeros. Clear with that topic? Okay, so this is the relationship between zeros of a polynomial and degree of a polynomial. How many zeros are there? It depends upon the degree. What the degree is, that much zeros will be there for a polynomial. Hope you understood that much, okay? Now, going to the next topic, geometric meaning of zeros of a polynomial. It's very important because geometric meaning means if an equation is given or if a polynomial is expressed. In 9th class we have studied that you can represent them in graph. There is a graphical representation method. You can represent any given equation into a graph. In 9th class, when we drawn the graph of a linear polynomial, what did you got? You got straight lines, right? Every time in x and y axis something, your graph will be a straight line. It may be straight, it may be a parallel to x axis, it might be parallel to y axis, it can be inclined like this. So anyhow you are going to get a straight line if it's a linear. So in the term linear itself it is there. What's the meaning of linear? Line, ear, linear, L-I-N-E-A-R, linear, something like a line. That's it. So that's the meaning of that one. When you're finding the geometric expression of a linear equation, you can understand that it will be represented as a straight line within the graph. What about a quadratic polynomial? If you're expressing a quadratic polynomial, if you're taking a quadratic polynomial and if you're drawing, say, y is equal to ax square plus bx plus c, a general form of a quadratic polynomial, means the degree should be 2, 3x square plus 2x plus 5, a quadratic polynomial of a general form. If you're trying to draw a graph for this one, you already know that, right? If you're trying to draw the graph of this one, you can see that you will get something like a U-shaped graph. It will be not a linear graph. You will get a U-shaped graph or an inverted U, means something like this. And this particular inversion or this particular U or this inverted U or this U, that particular diagram is what we call parabola. It's called parabolas, okay, parabolas. So these parabolas you can see. And when you are drawing, and if you got a parabola or an inverted parabola, it means that the equation is of quadratic. It means the saying the shape, you can say whether it is a linear equation or whether it is a quadratic equation. And if you are drawing a quadratic equation by some given measurements, if you are simply drawing some, means if an equation is given, different equations are given and you are trying to draw a quadratic equation. When you are representing them over graph, you can find something. You can notice that the graph, it can lie above the x-axis, means above the line, without touching the x-axis, it can be above, means it will be within the first and the second quadrant. In another case, this parabola can be downwards, like this, towards the down. That's the second case. Third case, this parabola is just touching the x-axis exactly at one point, something like a tangent. It is just touching the parabola. The parabola is just touching the x-axis exactly at one point, just touching exactly at one point. Fourth method, the parabola is touching 2 points at x-axis and going out. So point number 1, the parabola does not touch the x-axis. Point number 2, the parabola again does not touch the x-axis, it's in the inverted way. Third one, the parabola just touches the x-axis. Fourth one, the parabola just intersects the x-axis in 2 different points. So these are the possibilities when you are trying to draw a quadratic equation. These 4 possibilities are there. So what does this mean? Is there any significant relationship between the diagram, or if it is touching the x-axis, is there any significance? Yes, there is. If you're drawing a linear equation, and if the linear equation, I told you it's of straight graph, it will be a straight line, right? If the straight line is intersecting x-axis, wherever it intersects the x-axis, that particular point is the zero of that equation. That means if you're drawing a linear equation and that line is touching at -1, that means that -1 will be the zero of this given graph. That means if you simplify the given linear equation, you will get -1 as the zero. Similarly, if you're taking a parabola, I told you what is a parabola. It's a graph represented from a quadratic polynomial, right? So quadratic polynomial, I told you what is quadratic. It has 2 zeros. So there are 3 cases right now. Means the zeros of the polynomial, anyhow there are 2 zeros. They can be distinct zeros. That means if the parabola is touching in 2 points of x-axis, it can be distinct different values of x. It can give 2 different values of x. And another case I told you, if the parabola is just touching only a single point on x-axis, that means even though it is a parabola, already we know there are 2 solutions for that one, right? There are 2 zeros. So even though there are 2 zeros, the 2 zeros will be exactly the same because it is touching only at a single point. Means if your parabola is touching at the point 2, it means that the solution or the zeros of the parabola or the zeros of the quadratic equation will be x is equal to 2 and x is equal to 2. Similar zeros, that's the meaning. In case number 1, I told you the parabola is not at all touching x-axis. Second case I told you it was in an inverted way, and there also it is not touching the x-axis. It means that there is no solution. So in conclusion, let me tell you that wherever the graph meets x-axis, that will be the 0, and you can count it as the 0 also. That means that graph will be a graph of a cubic polynomial. That's also should come into your mind, right? If it is cutting exactly at 4 points, yeah, that's a graph of biquadratic polynomial. So this is how you have to understand by graph how many zeros are there. If you understood how many zeros are there, you can say of which degree it is. If you know what the degree is, then you can say the name, whether it is linear, quadratic, cubic or biquadratic. Clear? So let us go to the first exercise, exercise number 2.1. Here there are 6 graphs given. Check out the first graph. You can see here the first graph, it is parallel to x-axis. That means it's not at all cutting the x-axis. If it is not cutting the x-axis, how many zeros are there? There is no zeros, right? It's not at all cutting x-axis, means there is no zeros. So the total number of zeros is 0 itself, there is no zeros. Second question, see the second graph. In this graph you can see that it is cutting, see this wave, this arc, it is just cutting the x-axis exactly at 1 point, right? You can see that it's only at one particular point it is cutting, only at 1 point. So how many zeros is there? Only a single zero. Third question, you can see that it's going like this, right? Something like an N or something like an N. So tell me how many zeros. One time it is cutting on the left hand side of x-axis, then it is coming up, and again on the right hand side 1 time, and again when it is going back, again the 3rd time. That means all together 3 times. That means 1 at the negative part of x and 2 of them at the positive. That means all together 3 zeros. Among them 1 is negative and the other 2 is positive. Fourth diagram. Here it's a parabola, so definitely it's a quadratic equation. It's cutting at 2 points on the left hand side. That means it is having 2 zeros and it will be negative also. Just keep that in your mind. It's not about this question. This question is all about to find the zeros. But I'm just giving a little bit more information from that one, okay? They are having 2 negative zeros. That's also the meaning. Question number 5. Question number 5. See here. You can see the graph is coming like this. How many times it is cutting? Just count how many times it is cutting x-axis. 2 times on the left hand side of the graph and 1 time on the right hand side of the x-axis. 2 times on the left and 1 time on the right. That means all together 3 times. Then again 1 more time, right? Not only 3, again 1 more time is there, right? Towards the last end. So there are 4 solutions for this. It means there are 4 zeros. So if there are 4 zeros, it's a biquadratic equation, right? There are 4 zeros. In 4 exactly per se, there are 2 negative zeros and 2 positive zeros. Final one more graph. See here, 1 time it is cutting the x-axis and now it is just touching the x-axis. So again 1 more time, 2 it's over. Again going and cutting the y-axis. We need not want to count the y-axis. Coming down, it's just touching x-axis 1 more time. So what does it mean? Exactly, just count on how many times it is cutting x-axis. 3 times. So we can say that the total number of zeros is 3. So this is the way how to understand graphically. Means the geometric meaning of zeros of a polynomial by using graph. That's what it means by geometric meaning. Okay. So if in geometry, if it is described like this, just by seeing the diagram, you can come to the conclusion that how many zeros are given there. So that's up from today's section. Thanks for watching.